For the test point, we do want to make sure that it is not going to be on our line. And when we plot 0, 0, we notice it's not, so that works. What you want to do is you want to plug in 0 for x and 0 for y into one of the inequalities. It doesn't matter which one. You can use the original inequality or our modified form. I'm going to use the original. So we plug in 0 for x and 0 for y. Simplify. We find 0 is less than 12, which is a true statement. That means the point 0, 0 lies in our solution set. So we shade everything on the same side of our line as 0, 0. What you see on your screen right now, the dotted line with the shading on the appropriate side, is the correct solution. And that's how you need to graph your solutions for linear inequalities in two variables. Do make special note that for the less than or equal than signs, we use the dashed or dotted line, and that if there is that equal sign underneath, we use a solid line. Here's the procedure once more if you need it. First step is to graph the related linear equality. So we replace the inequality sign with an equal sign and graph that line. Make sure that if the original sign was a strict inequality, either less than or equal to, we use a dashed line. Otherwise, we can use a solid line. Step 2 is to use a test point. Make sure that the point is not already on the line to see what side of the line we should shade. Let's look at some more examples. In example 2, we have x minus y is less than or equal to 0. And then we have x is greater than 3. Go ahead, try these examples on your own. Pause the video, and when you're ready, resume to check your solution. Okay, let's start with part A. X minus y is less than or equal to 0. We want to graph this line, and for me, it's easier to, well, first we'll replace the inequality, and then to put this into slope-intercept form. We get y equals x. Whoa, giant graph. I don't think this thing ends. Okay, let's look for a different solution. Well, clearly my graphing utility is being a little finicky today. Also not allowing me to delete. Ooh, there we go. So I will just go ahead and draw the Cartesian plane myself. Get x and y. 1, 2, 3, 4. Then we get the same increments going up and down. Our y equals x line goes to the point 0, 0, 1, 1, 2, 2, and so on. And notice, since we do have less than or equal to, we can draw a straight line. Now for our test point, the point 0, 0 doesn't work because that's already on our graph. Let's pick a different point. Let's pick the point 3, 0. So we plug in 3 for x and 0 for y into our original inequality. 3 minus 0 is less than or equal to 0. Get 3 is less than or equal to 0, which is incorrect. So the point 3, 0 is not in our solution, meaning everything else on the other side is.